All right, so let's look at your first set of problems in 10.4, which is talking about vectors. So just to introduce it, when you're talking about a vector, or at least just the geometric ones that we're looking at in these first few problems, a vector is something that has both magnitude, which means that it has a size, and it has direction. So whenever you're talking about a vector, you're looking at the basically the length of these arrows as well as the direction that the arrow is pointing in. So this first problem is asking us to add v plus w. So here are our vectors. So vector v is just an arrow that runs horizontally 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And then vector w has two directions. It runs both vertically and horizontally. So we take both of those into account. So you have vector v, which is 9 units going to the right, and then vector w, which goes to the right 1, 2, 3, 4, 5, 6 units, and it goes up vertically 1, 2, 3, 4, 4 units. So if you're taking vector v plus w, then you're going to have basically vector v just in the plane in general, no specific location yet. And then whatever you have vector v, and then you take vector w and you just would add it onto the end of vector v. So basically it would extend out here. You would have vector w going up in this direction. So when you add the vectors together, you just take one and you put it at the end of the arrow of the other. So basically this would be v, and then plus w would go up 4 units and then to the right 6 units. So your vector v plus w is going to be another line that starts at the same place as v, and then it would end where w ends after you add the two arrows onto each other. So this looks like the correct answer would be answer choice D. You have vector v, and then you add w onto the end of it, and v plus w simply starts at the beginning and then it finishes at the end of the arrows once you add those two together. So this one is answer choice D. Next, we are now multiplying vectors by a coefficient which is called a scalar. So we're multiplying vector v by 2. So basically whatever v is, we're just going to double it. We're going to double its length. So v is a vector that's going down 2 units. So if we double that, that just means it's going to be going down 4 units. So it would still be going down. It looks like it could be B or D. C looks like it would have the appropriate length, but notice, I'm sorry, A and C look like they would have the appropriate length, but they're going up. And our vector is going down. We just doubled the distance. So it should be going down 4 units. So let's count 1, 2, 3, 4. So B is the correct answer. Now we have v minus w. So whenever you have a negative vector, whatever vector is negative, you just move that one in the opposite direction. So negative v will be the same length, it's just the arrow will be pointing towards the left in this case. And if we have negative w, like which we do in this problem, then instead of the arrow pointing going up to the right, it will be pointing down to the left, and it would be the same distance. It's just moving in the opposite direction. So we have v, so we'll have the same vector going to the right, and then w, instead of going up to the right, it'll be going down to the left instead. So let's look at it and count it. So v goes to the right 1, 2, 3, 4, 5, 6, 7 units. And then w goes to the right 1, 2, 3, 4 units. And it goes up 1, 2, 3, 4 units. So when we subtract w, instead of going right 4 and up 4, we'll go down 4 and to the left 4. So then your final vector will start here at the beginning of v, and then it will go to the end where w will be after you add w's arrow to the tip of the v arrow. So your red arrow should be going from the beginning of v to the end of w after you reverse this direction. So here's v, Here's minus W going back in the other direction, but this arrow goes towards the starting point. This arrow is going in the opposite direction. The arrow should go from the beginning to the end after you apply your movements. So this correct answer choice is C. Now we have just a more complicated problem, but we're doing the same thing that we did in the first few. So we are multiplying by scalars so that we'll stretch the length of the arrows, and we are combining them together. Notice that W is negative. So after we stretch it by 3, we're just going to move it back in the opposite direction. So let's see. So if we have 3V and normal V is 1, 2, 3, 4 units up, then we're going to start out by going 12 units up, and then we add U, so we go down 1 and to the right 2. So we would be starting out by going really mostly vertical, and then it would be tilted down to the right a little bit. So the normal arrow, instead of just going straight up 12 units, it will move over to the right slightly because of the U arrow. But then we also have minus 3W. So W moves up 2 and to the right 1. So 3W will move up 6 and to the right 3. But also it's going in the opposite direction. So after we go up 12 and then over to the right 2 and down 1 using 3V plus U, then we also have to reverse this direction and basically move it back down to the left a little bit. So so when your arrow makes all of those movements, it'll end up kind of close to the same position. So let's see if we can kind of just eyeball it based on these. So it wouldn't be B or C because we know it ultimately ends up coming back to shrink the arrow a little bit. So it wouldn't be as long as these two arrows. So now it's a question of whether or not it would be A or D. And it looks like A will be the correct answer choice because D will probably just be going too far. So now C plus H equals K. So let's see where C is. Here's vector C. And if you add H onto it, you would end up basically with this arrow K. So this one is true. Now we have K equals H plus F plus A. So here is H. If we add F onto it, we continue going on in this direction. And if we add A to it, then we go in this direction. And we're trying to see if that equals K. So here's where our arrow started, and here's where it finished. It does look like K does span that distance, but K has the wrong direction. K is going in the opposite direction, so it would be correct if it had negative K instead. So this one is false. Now we have G plus F equals C plus H. So this would be a true statement if both sides start and end in the same place. So let's see. Here's G going to the left plus F, and I'm just following the directions of the arrows. So G plus F will be an arrow going up vertically like this. And then C plus H ends up down here, whereas G plus F ends up at the top. So even though they span the same distance, they are negatives or they are opposites of each other. So this one is false. Now we have E plus G plus H plus D equals 0. It will equal 0 if basically it starts, if it ends at the same place it starts. So basically we would be doing some sort of a loop. So let's see. Here's E going here, and then we add G, and then we add H, and then we add D, and we do end up in the same place that we started. So we're netting where our total distance traveled would be 0. So this is a true statement. So we're going to be switching over to the paper soon, but this one is simple enough to just explain here. If you have the magnitude of a vector and it equals 6, well, if you do 10 times that vector, then that will just give you 60. And now we're going to be switching over to the paper in the next video.